Now we go to fundamental problem 1, right? You have the block, right? And then of course it's on the surface, on the floor, and then there is an applied force E, right? With a direction of 3, 4, and 5, 3, 4, and 5. Right, and then the question asks you to find the friction developed between this 50 kilogram crate and the ground. If first, if P equals to 200 Newton, right? And second one, when P equals to 400 Newton. Okay, and then you are given the coefficient of static and kinetic friction between the crate and the ground to be this one. Right, this is of the coefficient of static friction US as 0.3, and the coefficient of kinetic friction UK equals to 0. Of course, UK obviously should be less than US, right? Okay. So we start with drawing the free body diagram. Okay. What do we have if we draw the free body diagram? First, we have the weight, right, which is 50 kilogram times 9.1, and it acts in the middle, at the center, right? And then what else you have? What else you have? You have the normal force, right? And then next, what else? You have the friction force F, right? How do I know that F goes this way? Because it must oppose the possible direction of the movement. If you can see that the P, actually the horizontal component of force P, the pushing force, it pushed to the left, right? So the F should resist that, so it goes to the right. Okay. So the first question: what happened? What is this F? Okay, the friction force if P equals to 200 Newton. Okay. Then what we have to do is we do this. In this case, the first case, this is 200. Okay, 200 Newton. Then we do the free. Okay, we do the. Okay, of course we have this x as well, right? The distance between the end and the center, and this is the point O. Okay. What we have to do is we do summation of forces in y direction equals to 0, right? And then what do we get? We have minus 50 times 9.1, which is the weight. What else? We have plus n, right? The normal force, and then we have the minus the vertical component of this P, which is minus P, which is 200, times what is the vertical component? It is 3/5, isn't it? Equals to 0. So from here, you can have your normal force N to be 610.5 Newton. Right? And then you do Fx equal to 0, the horizontal component, okay, assuming positive to the right. You have plus F, okay, minus P, the times 4.5, which is the horizontal component of it. Okay, and then this one equals to F equals to 160 Newton. Okay, what do we have to do next? This is the friction force, right? What we have to do is, actually the question asks you to find what is the friction force. This is the friction force in this case for A when P equals to 200, but you need to check whether this friction force is correct. I mean, this is valid or not. So how do you check that? So you check it by using this limiting static friction force, which is mu s times n, right? And then mu s is coefficient of static friction is 0.3, and your n is 610.5 Then you got your limiting static friction force Fs to be 183.15 Newton. Okay, why this is important to look at this? Can you see that? Can you see that actually in this case, when you apply P equals to 200 Newton, your F, which is 160, it is less than your Fs, which is the maximum, the limited static friction force. What does it mean by that? It is less than this. So it means that actually the crane does not slip. It doesn't move. Why? Because this friction force is less than the limiting. It doesn't reach the limiting yet. Okay? It doesn't reach the limiting, so actually it doesn't move. Alright? Okay, next we go to the second one, which is if your P is 400, not 200. So what happened? Just now it was 200, right? Now you do it if it is 400. So it is the same procedure, by the way. So what you have to do is you do Fy equals to 0, right? And then what you have minus 50 times 9.1, which is the weight. You have plus N, which is the normal force going up, and then minus P, in this case is 400, okay? Minus 400, 3 over 5, okay? And then because it's in equilibrium, so it is equal to 0. So your N, your normal force, in this case, it is bigger, which is 730.5 Newton. Right? And then you do Fx equals to 0 because you want to find what is your F, okay, the friction force. So you have F minus P, which is 400. The horizontal component of it, the x component of it is 4 over 5. Right? Equals to 0. So from here, you have your F, your friction force in this case, it is 320 Newton. Okay, and then again, you check for your limiting friction force, mu Sn, okay, and your mu Sn, your mu S is 0.3, okay, and then your N is N from here, which is 730.5, right, and then your F, the friction, Fs, the friction force is, not friction force, the limiting friction force, the maximum static friction force is 219.15 Newton. Okay, what do you see here? Can you see that in this case now, your friction force in this problem is bigger than your Fs, right? Isn't it? Is it the case? It's bigger. Okay, instead of 219, now it has exceeded 290. It is 220. So because you know that this because from your calculation you see that this F is bigger than Fs, which means that you create slips. Alright, and then you have to find your kinetic friction force, which is mu k times N, right? Your mu k is 0.2 and your N is how much? 730.5. Right, and then it is 146.1 Newton. So what happens is when the crate slips due to you apply your force, your pushing force of 400 Newton, the crate slips and the friction force now becomes the kinetic friction force with the magnitude of 146.1 Newton. Right? Can you see that this is much lesser? Why? Because now it has moved. When it moves, then it becomes smaller, the friction. You can see yourself. I mean, if you try to push something, before it moves, it's very hard to push, right? But once it has started to move, you can push it very easily, right?